Let us look at book 10, proposition 32 of Euclid's Elements. So here we have to figure out two medial lines commensurable in square only, and the rectangle contained by them should also be medial. Also, the square on DM is greater than square on DL by square on LM, where LM is commensurable with DM. So let's see how we can arrive at such medial lines. So we start off by taking three straight lines A, B, and C, which are commensurable in square only. Get these, we start with a straight line A, then we take two square numbers P square and Q square, such that P square is greater than Q square, and the difference between these two is not a perfect square. So we arrive at B. Similarly, we again take two other square numbers B square and D square, such that the difference between them is not a perfect square. And again, B is greater than D. So this is what we arrive at. We have already seen this in our previous sessions. Now, let's start off with figuring out DM and E. For DM, we take a line which is the mean proportional between A and B. So again, here you can think of it like this. DM is equal to square root of A times B, or DM square is equal to A times B. In proportionality form, we can write it as A is to DM is equal to DM is to B. Then we take the next straight line, that is E. This we take it as B times C divided by DM. And again, we can think of it as DM times E is equal to B times C. Okay, so these are the required straight lines. Now we have to show that they are medials commensurable in square only, and their product or the rectangle contained by them is medial. DM will be square root of A times B. So let's do the substitutions. Square root of A times square root of 1 minus Q square by P square. Now A square, we can take it out of the square root. So we are left with fourth root of 1 minus Q square by P square, which we write it in this form. Next, let's take E. E is equal to B times C by DM. So again, let's do substitutions. We get B, that is A times square root of 1 minus Q square by P square, times C. C is A times square root of 1 minus D square by B square divided by DM. DM is A times 1 minus Q square by P square to the power of 1 by 4, or the fourth root. This can be simplified to, here one of the A's will cancel out. We are left with 1A times, now here 1 minus Q square by P square can be written as to the power of 1 by 2. In the denominator, we have to the power of 1 by 4. So 1 by 2 minus 1 by 4 is 1 by 4 times 1 minus D square by B square to the power of 1 by 2. Now let's look at their product. DM times E is equal to A times A square, 1 minus Q square by P square, 1 by 4 plus 1 by 4, that is 1 by 2, times 1 minus D square by B square to the power of 1 by 2. And this is medial. Now, how can we say that it is a medial? Because if you remember, in a previous session, I said medial is you have a 1 by 4 power, or fourth root you will have. So the way to look at this is that DM times E is an area of a rectangle. Now, if we have a square of the same area, then the side of that would be medial. Side of that would be square root of this. So here we can say that this is a medial rectangle. That square would be a medial square. And the side of that square would be medial. So that's how this is a medial rectangle. Okay. If we draw the rectangle, then FK is equal to E. And the area of this rectangle is medial. So we have found two medials commensurable in square only. Now, what about commensurable in square only? Now, here you will notice that you have A times 1 minus Q square by P square to the power of 1 by 4 common. But this is a square root. That means they both are not commensurable. But if we take the squares on both of them, then this square root will disappear, which means they would be commensurable. So that means they are commensurable in square only. Okay, great. Now let's look at the last one. dm square is greater than dl square by lm square, where lm is commensurable with dm. So we have already seen how to do this previously. So what we do is we draw a semicircle and we draw a circle with center at D and radius as E. So we take the intersection and we join DL and we join LM. So here DM and DL are commensurable in square only because DL is equal to E. So we have LM. So we have to show that LM is commensurable with DM because this is already clearly established. Because dm square is equal to dl square plus lm square by Pythagoras theorem, which can be written in this form. So now let's figure out what is lm. Because why we have to figure out all these things is because if I just ask GeoGebra to display the values of this dm, dl and d times e, e is nothing but dl. So by just looking at this, we can't say much because this may be a rounded figure or it might be a truly irrational number where the decimals keep continuing. Since GeoGebra can't display that, it will do the rounding. So that is why by looking at these values, we can't figure out that. So that is why we have to expand it out. So let's do that. Now here, LM is equal to square root of dm square minus dl square, which is equal to square root of dm square. So square of this will be what? A square times the square of this. Square of this will be 2 by 4 minus square of dl, that is E. So A square times 1 minus q square by p square to the power of 2 by 4 times 1 minus b square by b square to the power of 2 by 2. So this gets simplified to a square is common to both of them. So we can take it out and then take it out of the square root itself so that we are left with a. A times, now here 1 minus q square by p square to the power of 1 by 2 is common to both the terms. So we take it out times 1 minus, this is taken out, 1 minus d square by b square to the power of 1. So that means in further simplification, what will happen is this 1 minus 1 will disappear and this minus times minus will become plus d square by b square. So this is a perfect square, so we take it out. So we end up with a times d by b times square root of 1 minus q square by p square to the power of 1 by 2, which is nothing but a times d by b times 1 minus q square by p square to the power of 1 by 4. And here you can clearly see that Lm is nothing but a multiple of or a rational multiple of dm. D by B is rational. So LM is D by B multiple of DM. So we have shown that LM is commensurable with DM. So that means we have completely taken care of this issue of finding two medial lines DM and E commensurable in square only, where the rectangle contained by them is medial and DM square is greater than DL square by LM square, where LM is commensurable with DM. So that is interesting, right? So that's it for now.